Hello, this is Dr. Hanaa Assil and this is paper 1C November 2023. This is in the Pearson Edexcel IGCSE chemistry. So, the first question in this exam was, a substance can exist in three states of matter, solid, liquid or gas. When a liquid evaporates at room temperature, it changes into a gas. Complete the diagram to show the arrangement of another 4 particles in a gas. So we want to draw 4 more particles if this is a gas. You should know that particles in a gas are randomly arranged, so they shouldn't be in any particular order, and they should be far apart, so it would be something like this. Explain why heating a liquid causes it to evaporate more quickly. Now, if we heat a liquid, it evaporates, and we said evaporation means the particles on the surface will change from liquid to gas, and that is because particles on the surface gain kinetic energy, move faster, more particles are able to overcome the attraction forces between them and move further apart, so they change into gas. Of course, evaporation happens on the surface of the liquid and at any temperature. That's the difference between it and boiling. When the temperature decreases, water in the gas state changes to a liquid. Give the name of this change of state. Remember, when he's asking for name of change of state, your answer is either melting, boiling, condensation, freezing, or sublimation. So what are we talking about here? Water in the gas changes to liquid. So gas changes to liquid. Remember, change of gas to liquid, that is called condensation. Please remember the meaning of all the others. So solid to liquid, melting. Liquid to gas, we say boiling. Sometimes it's allowed to say evaporation, but actually it is boiling. Gas to liquid, condensation. Liquid to solid, freezing. And of course, sublimation is the change from solid to gas or gas to solid. Write an equation including state symbols to show the change of state of water from gas to liquid. So we're required to write an equation, and that means symbol and balanced. We also need state symbols, and we're trying to write an equation that shows change of state of water. So we're talking about water, and you should know water is H2O, from gas to liquid. And that just means I'm starting with water, H2O, in the form of a gas. So remember, the state symbol is G. Going to water as a liquid, state symbol L. Of course, this is balanced, so this is the required equation. Describe the arrangement and movement of particles in a solid. Now, when we are required to explain about one of these, please note the question is asking about explanation of what. For example, here we're talking about arrangement and movement, and you should know the difference in arrangement and movement between solids, liquids, and gases. So here we're required to talk about solid. You should know that solid is regular rows close packed. So that is the arrangement and separation. Movement, solids vibrate in fixed position. You should also know the explanation for liquid and for gases. So liquids and gases are randomly arranged, and liquids move around each other, or we say slide over each other, while gas particles move fast, free, random motion. Table 1 shows some relative masses and charges of subatomic particles. First of all, you should know the word subatomic particles means the particles inside the atom, which are protons, neutrons, and electrons. These are referred to as subatomic particles. Of course, protons and neutrons are inside the nucleus, and electrons are evolving in energy levels around it. Now, what are we required to write here? We're required to write the masses and the charge, and you should know, if we're talking about a proton, what is the mass of a proton there? You should know that the mass of the proton is the same as the mass of the neutron, and both of them are given a mass of 1. Now, if we're talking about the electron, the table says the mass of the electron 0.0005, or we write it as 1 over 1840. Now, what about the charge? What's the charge on an electron? An electron is -1. We say it is negatively charged. When we're required to write the charge, we write it -1. And of course, the proton is positively charged, so its charge is +1. Okay, then the question says, Table B gives the numbers of protons, neutrons, and electrons in atoms and ions of some elements. The letters are not the symbols. So, what is the atomic number of P? Well, where is P? P is the first one. What does atomic number mean? We said the atomic number is the number of protons. Atomic number. If we're required to say what is meant by atomic number, it is the number of protons. What is the mass number of U? Where is U? U is the last one down there. What do we mean by mass number? You should know that mass number is the total protons and neutrons in the nucleus. So, U has 8 protons, 8 neutrons, so its mass number is 16. Give the letter that represents an element in group 5 of the periodic table. How do I know which group? You should know that the group number is the same as the number of electrons in outer shell. In outer shell. So we're looking for something that has electrons. When distributed, the outer shell would have 5. So where is that? Well, if we look at S, S has a total of 7 electrons. If I distribute the electrons, you know that the first shell takes 2, the second shell takes 5. So this element would be in group 5. Q and R represent isotopes of the same element. Explain in terms of subatomic particles why Q and R are isotopes. Now, what do we mean by isotopes? You should know that isotopes are atoms of the same element, so they have the same what? The same number of protons but different number of neutrons. Now, we are required to refer to Q and R in the table. Now, why are we saying Q and R are isotopes? Well, because both of them have 5 protons, but they have different neutrons. Q has 5 while R has 6. So you have to refer to the Q and R in the table because that is mentioned in the question. Otherwise, if the question just says what is meant by isotopes, we just say same number of protons, different number of neutrons. A sample containing isotopes Q and R has this percentage composition. Calculate the relative atomic mass of this sample of the element. How do we calculate relative atomic mass from the percentages? Remember we said it is the mass number times the percentage. So what is the mass number of Q? The mass number of Q, we said, is protons plus neutrons. So Q has a mass number of 10, so we say the percentage times 10, plus R has a mass number of 5 plus 6, that's 11. So over 100, this gives me the percentage. But is this the final answer? Please, when you do these questions, check. Did the question ask for a specific number of decimal places or significant figures? Yes. The question says, give your answer to 1 decimal place, round up correctly. So this, when we write it in 1 decimal place, it's not 10.7. It's 10.8 because the next number is more than 5. Crude oil is an important source of organic compounds. The diagram shows how crude oil can be separated into useful mixtures of hydrocarbons. Give the name of this method of separation. Remember, to separate the constituents of crude oil, we use fractional distillation. This method is called fractional distillation. State what happens to the crude oil in X. So the first thing that we do to the crude oil is it is heated and vaporized so that it goes into that fractionating column in the form of a vapor or gas, and then it is cooled and condensed at different boiling points. Give the letter of the mixture that is most likely to contain a hydrocarbon with 6 carbon atoms. Remember, when we separate them, you are required, first of all, to know the order in which they come out and the uses for each one. And you should know that the ones at the top, the ones collected at the top, are the ones with less number of carbons, lower boiling points. So when we talk about refinery gases, remember most of these are alkanes. Alkanes are gases if we have 1 or 2 or 3 or 4 or 5 carbon atoms. So these are methane, ethane, propane, butane, pentane. But if I'm looking for something with 6 carbon atoms, then it is probably the next fraction, which is gasoline, which the question says is E. So remember, the refinery gases have less than 5 or less carbons, and as we go down, they have more and more carbons, so something that has 6 would be the gasoline. Give the name of mixture D. Now, which one is below gasoline? That is kerosene. Give a use for mixture B. Now, which one is mixture B? You should know that the one collected there is the fuel oil, and fuel oil is used as fuel for ships or for heating and cooking. Explain in terms of intermolecular forces why a hydrocarbon in B has a higher boiling point than a hydrocarbon in D. Remember, we said as we go down, they have more carbons, and that means larger molecules, and the larger molecules have higher boiling points, because when a molecule is, of course, all of these are simple molecular structures, they're not giant, but as we go down, the molecules are larger and larger, so there is stronger attraction forces between molecules that need more energy to be broken, or a larger amount of energy to be broken. Catalytic cracking can be used to break down long-chain hydrocarbons to produce shorter chains. Give the name of the catalyst in catalytic cracking. Remember, cracking is breakdown of long-chain hydrocarbons into shorter chains. Now, what is the catalyst? We said aluminium oxide catalyst, and if we're asked about the temperature, it's about 600 to 700 degrees Celsius. Now, complete the equation to show, and please read the question till the end to know what is required. Complete the equation to show two different alkenes that could be produced in this cracking. Now, if I'm starting with something that has 15 carbons, then the total number of carbons after the arrow should be 15. Now, if I remove 8 from it, then I'm left with what? I'm left with 7 carbons. I want to distribute them on two different alkenes. So let's say one of them will have 3, then the other one has 4. So that's a total of 7 carbons plus 8, that's 15. Now the hydrogens. First of all, we were told that these are alkenes, and you should know general formula of alkenes is CnH2n. That means number of hydrogens should be twice the carbons. So without counting, I should know that an alkene with 3 carbons should have 6 hydrogens. Alkene with 4 carbons should have 8 hydrogens. And then the total hydrogens after the arrow should be equal to the number of hydrogens before the arrow. So this is your answer. Give one important use for short chain alkenes. So what comes out from cracking, we said, are things like ethene, propene, butene. We said, what do we use these for? Well, we use the alkenes either to make polymers, or we use them to make alcohols like ethanol. Remember, we said we use ethene to make ethanol. We add steam, phosphoric acid catalyst, 300 degrees Celsius, 60 to 70 atm. This is how we prepare ethanol from ethene. So we use alkenes to make polymers, or you could say to make alcohol. Then the table gives information about 5 gases, and the question is, use information from the table to answer these questions. Each gas may be used once, more than once, or not at all. Give the name of the gas that is highest percentage in air, 79% in air. Which of these gases is 79% in air? You should know that that is nitrogen. Remember, air is mostly nitrogen, 78% or 79%. The oxygen is 21%. Carbon dioxide is about 0.04%. And argon is about 0.9%. Give the name of the gas that's a compound. Which of these is a compound? Remember, what's a compound? A compound is made up of different elements chemically combined together. So which one has different elements combined together? That is carbon dioxide. Give the name of the least reactive gas. What do we mean by least reactive? It means the one in group 0. If you look at the periodic table, and of course you have a copy of the periodic table in the exam, look at the one in group 0 or group 8. That is argon. Give the name of the gas that's not normally found in the atmosphere. Which of these is not? In air, you should know that air does not contain hydrogen. Give the name of the gas that affects global warming. Remember, global warming is carbon dioxide, and we said carbon dioxide and methane cause greenhouse effect because these gases in the atmosphere trap the heat from the sun, so the heat is not allowed to be reflected back out to the atmosphere, so the heat is trapped around the earth. This raises the temperature of the earth, causing global warming. So which gases cause that? You should know carbon dioxide and methane. Calculate the MR of carbon dioxide. how do we calculate MR? That is the molecular mass, and we look at the periodic table. We look for the mass number, which is the big number. So carbon dioxide is CO2. The mass number of carbon is 12. Oxygen, mass number 16, and I have 2 of them. So the molecular mass for carbon dioxide is 44. Give a reason why it's not possible to give information for air. This table is given molecular masses of gases. So we're told argon is 40, hydrogen is 2, oxygen, and so on. Why is it that I cannot calculate molecular mass of air? Well, air is not just one gas, it is a mixture of gases. So we do not calculate for a mixture of gases. When copper carbonate is heated, the products are copper oxide and carbon dioxide. So we're told that we're going to heat copper carbonate. It breaks up to give copper oxide and carbon dioxide. When we heat a substance and it breaks up, what type of reaction is that? That is called thermal decomposition. Now, there are some colors that you are required to know. So you should know the color of copper carbonate, and you should know the color of copper oxide, and we should know that copper carbonate is green. So the question says give the color change. When we heat copper carbonate, which is green, it becomes copper oxide, and we should know that copper oxide is a black solid. Now give a chemical equation. Again, that means symbol and balanced. We're starting with copper carbonate. How do I write copper carbonate? I write the symbols and then the valency of one under the other. But here valency of copper is 2. That is written up there, and you should know that the valency of copper is 2. Valency of carbonate also is 2, so you don't write 2 anywhere. They cancel. Copper oxide, valency of copper is 2, valency of oxygen is 2. So you don't write 2 anywhere, they cancel. So this is the equation. Is it balanced? Please do not leave a chemical equation without checking if it's balanced or does it need balancing. So copper carbonate to give copper oxide plus CO2, this is an already balanced equation, so we can move on. So question 5 says, this question is about alkanes and alkenes. What is meant by isomers? You should know these definitions. Please learn them. Isomers are compounds, organic compounds actually, having the same molecular formula. And you should know that molecular formula means the same number of carbons, same number of hydrogens, and so on. So same molecular formula, but different what? You can either say different structures or different displayed formulas. Now we're required to draw the displayed formula of 2 isomers of what? C4H10. Now you need first to ask yourself, C4H10 is alkane or alkene? C4H10, the hydrogen is more than twice the carbon. It's an alkane. Alkane means it has single bonds. So I need to draw an alkane with 4 carbons in 2 different ways. That's what we mean by isomers. So how do I draw them? I can draw once all the 4 carbons after each other in a straight chain, and of course each carbon must have a total of 4 bonds. So we complete them with hydrogens. Please do not forget to write the hydrogens. What would be the isomer? How can I draw this in a different way? Instead of having all the 4 carbons after each other, I put one of them in the middle, not on one end, in the middle. Please don't put that CH3 on one end, because that would be the same as the first one. So we take one of the carbons, put it in the middle, complete the structure so that all the carbons have a total of 4 bonds. Ethane can react with bromine. Remember, we have reaction of alkanes with bromine or halogens in general, bromine or chlorine. For an alkane, because we have another one in which we have alkene. For an alkane reacting with halogen, what are the conditions? We said this alkane is not a very reactive molecule, so we need ultraviolet light or UV light to start the reaction or to make it faster. So we said this is an example of a photochemical reaction. Complete the equation. Now, when we start with an alkane and I'm reacting it with bromine, what happens? We remove one of the hydrogens, and replace it with a bromine. So instead of C2H6, I now have C2H5Br. And my other product is the hydrogen I removed and the other Br. So my other product is hydrogen bromide. That's how it's written. And of course, this equation is balanced. Give the name of this reaction. This type of reaction is a substitution reaction. So remember, alkanes with bromine. Substitution reaction requires UV light. Remove one of the hydrogens and replace it with the halogen. Explain why ethane is described as a saturated compound. This is ethane. Why do we say this is saturated? We refer to an organic compound as saturated because it has only single bonds between the carbons, no double bond between the carbons. Remember, when we talk about solutions, saturated has a completely different definition. A saturated solution is one in which no more solid can dissolve. A saturated organic compound is the one that has only single bonds, no double bond. State what you would observe when ethane and ethene are added separately to 2 samples of bromine water. Remember, ethane and ethene, which one would react with bromine water? Bromine water is the test for alkenes or test for unsaturation. So if I add it to an alkane, no change. But if I add it to an alkene, it turns from orange to colorless. Bromine water is originally orange. If I add it to any alkene, it turns colorless. Explain why straight chain alkenes always have the same empirical formula, but straight chain alkanes have different empirical formula. Refer to the molecular formula of alkane, C2H6 and C4H10. First of all, what do we mean by empirical formula? You should know that empirical formula is the formula showing the simplest ratio. Molecular formula shows the actual ratio. So if we're talking about alkene, you should know that alkenes, general formula CnH2n, so the number of hydrogens is always twice the number of carbons, so its empirical formula is CH2. So that's for alkenes. What about alkanes? You should know that alkanes have general formula CnH2n plus 2. You're required to know that. And that means if I have C2H6, I want to simplify the 2 and 6. That would be dividing by 2, so that's 1 to 3. So the empirical formula of C2H6 is CH3. But if I do the same for C4H10, you divide by 2, then the empirical formula is C2H5. So alkanes have different empirical formula. Alkenes have the same empirical formula, which is CH2. An organic compound has this percentage composition by mass. Calculate the empirical formula. Again, we said empirical formula means the formula showing the simplest ratio. Now, when we're given percentages, so we have percentage of carbon, hydrogen, oxygen, Br. And we're required to get the empirical formula. We said, how do we do that? First, we divide by the mass number. Again, the mass number is the big one in the periodic table, not the small one. So, mass number of carbon is 12, not 6. Hydrogen is 1, oxygen is 16, not 8, and Br is 80. Now, what comes out from this? So, the first step, divide by mass number. And then the numbers that come out, divide by the smallest. And that gives you the simplest ratio, empirical formula. You have to write the empirical formula. Don't stop at the ratios. So we got the ratios 2 to 5 to 1 to 1. That means the empirical formula is C2H5OBr. A student uses this apparatus to investigate the decomposition of hydrogen peroxide solution. And this is the equation for the reaction. First, give the test for oxygen. What is the test for oxygen gas? Please learn the tests. Is it lighted splint or glowing splint? Please do not mix it up. You should know that. Testing for oxygen, I use what? A glowing splint. Insert a glowing splint, it relights. That's the test for oxygen. If we were talking about hydrogen, we would say insert a lighted splint, it pops. Complete the dot and cross diagram for a molecule of hydrogen peroxide. Show outer electrons only. Again, when we draw dot and cross, first of all, these are hydrogen and oxygen, two non-metals, so they're going to share. That's the first thing. Share electrons depending on how many electrons each of them needs. So if I look at the hydrogen, hydrogen has 1 and it needs 1 because this is the first energy level. So for each hydrogen, I'm going to take 1 from the oxygen, 1 from the hydrogen and share. And the oxygens have 6 electrons in their outer shell. And that means they need 2 because a shell is filled if it has a total of 8. So it needs 2, so each oxygen is going to share 1 with the hydrogen and 1 with the neighboring oxygen. So this is the dot and cross for hydrogen peroxide. The student measures the volume of oxygen collected at regular intervals until the reaction stops, and we're given a table and we are required to plot the student's results on the grid and draw a curve of best fit. Please read the instructions. So, what should we do? These information in the table we need to plot onto the graph paper or the grid. The X and Y axes are already labeled. Remember, if they're not labeled, then you have to label them. And the one that is on top is the one that goes on the X axis. So time in seconds is down, volume of oxygen in, and you include units, is on the Y axis. But this is already written there and they already distributed. So all you need to do is plot the points, and the question says draw a curve of best fit. Please include the points as much as possible. If there is a point that's away from the curve, then you do not include it, and that's what we call an anomalous result. So, explain in terms of particle collision theory how decreasing the concentration affects the rate. Now, if I'm using less concentrated acid, for example, the question says explain the effect. So you have to tell me the effect on the rate and why. First of all, if I'm using less concentration, what happens to the rate? The rate decreases. Using dilute acid instead of concentrated acid, the rate decreases. Now, why does the rate decrease? Because when I'm using something of less concentration, then there are less particles, so less frequent collisions, or you could say less collisions per minute. So either less frequent collisions or less collisions per minute. The student repeats the experiment using the same volume of hydrogen peroxide but half the original concentration. All other conditions are kept the same. So if I have this graph and I say we're going to repeat this experiment using half the original concentration of hydrogen peroxide. Remember, the hydrogen peroxide is the reactant here. So if I use half of it, will it give the same volume of gas? Remember, using half of it will be, first of all, it's slower. Slower means it does not end up like the original one. So if we're saying half the original concentration, that means it will give half the final amount of gas. So that first one gave about 94 centimeter cubed of gas. Then this one will give a total of half, and it will be slower. That means it will end at a time after 120 seconds. So that first graph up there ended at about 120 seconds. Now mine should not become flat before that. It has to become flat after that because it's a slower reaction. In this reaction, the manganese oxide acts as a catalyst. Explain how a catalyst works. Now, this question does not say what is meant by catalyst. So don't tell me a catalyst speeds up a reaction without being changed. That's not the question. The question says explain how a catalyst works. Remember, a catalyst provides an alternative pathway with lower activation energy. So if we're drawing the energy diagram there, the activation energy is the difference in energy between reactants and the top. Reactants and the top. Now, if I'm using a catalyst, that activation energy is lower, so I get that red graph if we're told to draw it on a graph. A technician needs to identify the solution in an unlabeled bottle. The technician knows that the solution contains one of these compounds. Describe how the technician can use chemical tests to identify the compound. Now, what are the choices that we have? It can either be iron 2 or iron 3. And it can either be a chloride or a bromide. So these are the tests that I need to write. So what was the test for iron 2 and iron 3? Remember, to distinguish between iron 2 and iron 3, we say add aqueous sodium hydroxide or add sodium hydroxide solution. The iron 2 should give a green precipitate. Iron 3 should give a red-brown precipitate. So, once we've distinguished whether it's iron 2 or iron 3, now I need to know, is it iron 2 or 3, bromide or chloride? So, what is the test to distinguish between chloride and bromide? Remember, that is the test in which we say aqueous or dilute nitric acid and aqueous silver nitrate or silver nitrate solution. What happens? Well, if I have a chloride, the choices I have here are chloride and bromide. So if it's a chloride, then we should get a white precipitate. And if it is bromide, we should obtain cream. Of course, you know that if we're testing for iodide, it should give a yellow precipitate. When chlorine gas is passed over heated iron powder, iron 3 chloride forms. This is the equation for the reaction. and we're told 0.06 mole of chlorine gas is passed over 2.8 grams of iron powder. Show by calculation that the iron is excess. Now, to determine whether one of the reactants is excess, I need to compare the number of moles of each. So we are given the number of moles of chlorine. We are told that we have 0.06 mole of chlorine. But we need to calculate the number of moles of iron. So what are we told about iron? That we have 2.8 grams. How do we get number of moles of iron? You should know that number of moles is mass over molecular mass. So mass is 2.8. I'm going to remind you the molecular mass is the mass of the substance. You do not look at the balancing. So the mass, the MR of iron is 56. It's not 2 times 56. I don't look at the balancing when I'm calculating MR. So MR is of that thing. Iron is 56. That's the mass number from the periodic table. That means I have 0.05 mole of iron. Now, to know which one is excess, now I look at the balancing in the equation. We're told that I have 0.06 mole of chlorine, and what they put was 0.05 mole of iron, but from the equation says 2 moles of iron react with 3 moles of chlorine. So if I have 0.06 mole of chlorine, how much of iron did I need? 2 reacts with 3. So how much would react with 0.06? I find that that is 0.04. So all I needed from iron is 0.04, but he actually added 0.05. So that is more than needed. That is why we say iron is excess. So we need from the equation, if I have 0.06, I need 0.04 of iron. But he put 0.05, that's too much. So iron is excess. When iron 3 chloride dissolves in water, an acidic solution forms. Give the color of litmus in acid. You should know, if we put litmus paper in acid, it should turn red. If it is in base, it turns blue. So give the formula of the ion that causes the solution to be acidic. Remember, any acid must have what in solution? Definition of acid is proton donor. What do we mean by proton? H plus ion. So if we're required to give the formula of the ion in acid, H plus. In base or alkali, it is OH minus. So if this question says give the formula of the ion that makes a solution alkaline, it's OH minus. Ion that causes a solution to be acidic, it's H plus. Diamond and graphite are made of carbon atoms joined together by covalent bonds. The diagram shows their structures, and the question says, state in terms of electrostatic attractions what is meant by a covalent bond. Again, if we're required to explain what is meant by covalent bond, please do not say it's a bond between two nonmetals. That's not the definition. A covalent bond is strong electrostatic attraction forces between what? The shared pair of negative electrons, so the electrons that are being shared, and the positive nuclei of the atoms, because I have two atoms sharing these electrons. So the covalent bond is the attraction between the electrons that are being shared and the positive nucleus of each of the atoms. So the positive nuclei, that's the plural, of the atoms and the shared pair of electrons which are negatively charged. Please learn this definition. This is definition for covalent bond. Explain why diamond has a high melting point. Remember, if we say diamond or graphite, this applies to diamond or graphite. Both of them have high melting point due to what? Due to the many strong covalent bonds in the giant three-dimensional structure that need a lot of energy to be broken. Remember, diamond or graphite have high melting point due to many strong covalent bonds in the giant three-dimensional structure that need a lot of energy to be broken. Explain why graphite is a good conductor of electricity. Remember, we said graphite is made up of carbon atoms and it is the only non-metal that can conduct electricity. Now, why does graphite conduct electricity? Due to the presence of delocalized electrons that are free to move. Graphite conducts electricity because it has free electrons due to the presence of delocalized electrons that are free to move. Remember, each carbon has a total of 4 electrons in its outermost shell. In graphite, it is using only 3 of them for bonding, so it has, each carbon atom has 1 free moving delocalized electron. That's what allows it to conduct electricity. C60 fullerene is a molecule made of 60 carbon atoms. The diagram shows the structure. 1 mole of atoms contains 6 times 10 to the power 23 atoms. Determine the number of atoms in 1 mole of C60. So you should know that the C60 has 60 carbon atoms. If I have 6 times 10 to the 23 atoms, that means we have a total, in 1 mole, that means we have a total of 60 times 6 times 10 to the 23. So this is the number of atoms in 1 mole of fullerene. Question 9 says a scientist uses this apparatus in an experiment to reduce a metal oxide to a metal. So I'm starting with metal oxide and we're passing hydrogen over it. This will change the metal oxide to metal. So magnesium oxide to magnesium, for example. Before heating, the mass of the empty tube and the mass of the tube and metal oxide are recorded. After heating, the tube is allowed to cool and the mass of the tube and its contents is recorded. State why the reaction of the metal oxide to form a metal is described as reduction. So if I'm starting, for example, magnesium oxide and I'm changing it to magnesium, why is this reduction? Because this is loss of oxygen. Remember, loss of oxygen is reduction. State why it's important to relight the hydrogen at the end of the tube if the flame goes out. Now, the hydrogen is passing over the metal oxide. Now, any unused hydrogen goes out from the end of the tube and we have to burn it before it goes out into the environment. Why is that? What is the hazard of hydrogen, or what is the danger of having hydrogen gas coming out? Hydrogen is flammable. If it escapes, it may explode. Explain why it is important to continue passing hydrogen into the tube and burning the hydrogen at the end of the tube until the contents have cooled down. Now, what are we doing? We're trying to change the metal oxide to metal. If I just stop everything and leave it, then the metal might go back and become oxidized. So we keep passing hydrogen over it until everything cools down to avoid reoxidation of the metal if the oxygen enters the tube. If I don't pass hydrogen in, then the air with oxygen will go in, and that means the metal might be reoxidized again, and this is something we do not want. Describe what should be done next to ensure that all the metal oxide has been converted into the metal. Remember what we said is we heated the tube. The tube is, we weighed before and after and so on. The tube is allowed to cool, and then we weigh it at the end. Now you should realize that if I'm starting with an oxide and I end up with only the metal, then what happens to the mass? The mass should go down, should decrease. How do I know that all the oxide has been changed to metal? Well, I need to reheat, cool, reweigh, and continue this until the mass doesn't decrease anymore. So, in these kinds of reactions, in order to know that the reaction has finished, I need to reheat, cool, reweigh until constant mass. In this experiment, a mass of 4.14 grams of metal is formed from 4.46 grams of metal oxide. So I started with 4.46 grams of oxide. I got 4.14 of metal. So how much oxygen? What would be the mass of oxygen? It's the difference. So the 4.46, we changed it into 4.14. The difference is the mass of oxygen, and we're required to calculate number of moles. Again, how do we get number of moles? But we're talking here about oxygen atoms. So this is divided by the mass number, and I get 0.02 mole. Now, the formula of the metal oxide is MO. That tells you that number of moles of O is the same as number of moles of M. So deduce the number of moles of M, it is the same. Now, what is the relative atomic mass of M? So I'm trying to get the MR from number of moles. How do we get MR? Remember, number of moles is mass over molecular mass. So the molecular mass is the mass over the number of moles. We are told that we have a mass of metal up there is 4.14. Divide by the number of moles that we got. We find that the atomic mass is 207. Now, the next question says, use the periodic table to identify M. So we're looking for something that has a mass of 207. Mass number 207. Which one has mass number 207? That is lead. Mass is the big number again. Okay, this method is used in an experiment to produce hydrated zinc nitrate crystals. So we're told pour 50 centimeter cubed of nitric acid into a beaker, add a spatula of zinc powder, add more zinc until it is excess, filter the mixture, obtain crystals of zinc nitrate. So, first of all, why are we filtering? Remember, we added excess zinc, so we're trying to get rid of the excess zinc. So we're filtering to remove the excess zinc, which would be collected as a residue in the filter paper. And then we're going to take the filtrate, and we're told to obtain. Describe how a pure dry sample of hydrated zinc nitrate crystals could be obtained from the filtrate. So I'm going to take the filtrate and I want to do crystallization. So what should we do? Heat to point of crystallization, then cool to form crystals. Please don't forget to say cool to form crystals. Then filter the crystals through filter paper and funnel, wash with a few drops of distilled water, dry between filter papers. This is how we do crystallization, obtain crystals from a filtrate. This equation represents the formation of hydrated zinc nitrate in the experiment. in another experiment, 9.75 grams of zinc is completely reacted with nitric acid. Show that the maximum mass of hydrated zinc nitrate that could be formed is about 45 grams. So we're given information about zinc, and we're required to get the mass of zinc nitrate. What is the first thing we should do? Remember, we have information about zinc, so I need to get number of moles of zinc. How do we get number of moles? Mass over molecular mass. Again, here we're looking for the mass number. Actually, no, it's not given. The mass number of zinc from the periodic table is 65. So, mass over molecular mass, this gives me the number of moles of zinc. Then, we look at the equation. What are we asked about? We're asked about zinc nitrate. So I look at the equation, relate the number of moles of zinc to the zinc nitrate, the product after the arrow. The equation says 1 mole of zinc gives 1 mole of zinc nitrate. And that means the number of moles of zinc that I calculated, that is the same for zinc nitrate. So number of moles of zinc nitrate is 0.15 mole. Now what are we asked to calculate? Calculate the mass. How do we get mass? Number of moles times mR. This gives a mass of 44.55 grams. If we're given information about something, you get the number of moles of that. Look at the equation, relate it to what we're asked about, and then calculate what he's asking for. Simple 3 steps. The actual yield of hydrated zinc nitrate crystals is 36.4. Calculate the percentage yield of hydrated zinc nitrate crystals. Okay, so we already calculated that the theoretical yield, what they should have obtained, is 44.55. But the actual yield is what? They actually got 36.4. How do we calculate percent yield? It is the actual over the theoretical that we calculated times 100. This is 81.7% yield. And that's the end of this paper. Thank you for listening. I hope this was clear, and good luck on your exams.